Hi, I'm Dr. Alexander NGENZI from University of Rwanda College of Science and Technology, Department of Computer and Software Engineering. Okay, so as we continue from where we have been talking about the types of signal processing, we say that we talked about analog, presented in a wandering signal or the continuous signal. As I presented, there's also what we call discrete signal that is at a certain level or certain interval is going to be divided in this way. So before it becomes into digitized, it has to pass in this way, which is a discrete itself here, and then it is purely, for example, a digital signal that we require in our processing. So those are the main processing. It depends. You can begin with analog signal. For example, if you put, if you type the letter onto your laptop or any machine, then the computer or mobile phone will only understand the digital form. So it has to go into various processing process, and it has to come up or displayed, again it will be displayed on the screen. So these are the types of processing. So I hope this portion is understood. Maybe if there is any question, I told you, you have to send to my email, and remember to subscribe and share and the likes on my YouTube channel. So without cutting short our course, we are continuing to explain about the introduction to DSP. So having had all this information, we have seen various definitions. We can, as you remember, the digital, the signal, the processing. But here we are going to talk about where did this originate? Where did it come from? And why? What is the history behind this? So this, the first digital process, the processing, we are talking about the history of signal processing, first signal processing in history. Processing, sorry. So we are going to talk about the history of the signal processing. It was during the Second World War when the army at the battle were just detecting the information that is coming from their enemies using radar system. Radar system. And this is nothing but radio detection and ranging. Detection and ranging. So take it like this. For example, if you are using radar system, I had a chance to go and to do my industrial attachment at the radar station, and I captured some of the very useful information. Remember, for example, if you are using radar system, suppose this is a globe. This is a globe. It's for example, say the space, Rwandan space, for example, and you want to detect the target which is coming to our territory, or Rwandan territory, or the space here. You need to understand that when, for example, here they are trying to detect the target. For example, take it, a target now is like, for example, the airplane that is coming to our territory. It comes to this side, and then the radar itself is going to detect where, at which stage, the target, for example, if this is an airplane here, is coming on this side, until it reaches to the level where the control tower at the airport, for example, will understand or speak to the people, the pilot who's piloting the airplane. So they will easily, the radar system will identify before even the control tower here at the airport can recognize this one, and then they will communicate that there is a target coming to this side. So likewise, when the first signal processing came in, when they were detecting how far or how distant it is from their enemies to their premises or to their place. So it came in that way. During the Second World War, remember it was between, I don't recall very well, 1945, I don't remember very well. These days, that's when there were a Second World War. And it was used as one of the first processing application, that was radar, and this was purely analog. Remember, I repeat again, it was purely analog. It was it was not yet a digital system. So they used the radar system to identify using analog signal, and this came, for example, obviously it came with problems, including the aging of the system, the stability of the system, the sensitivity of the system. All those were the hindrances of this system during the Second World War. And to overcome these problems, the analog signal was to be transformed, for example, from analog signal to digital signal. Recently in when the transistor age came, 1970s, when the digital age started to arise, and when the transistor age tried to come up with solutions. But the presentation of signal, the analog signal was not able, it was not easy for them to manipulate. They used to see the signal as it is. For example, if I use my voice signal as an analog signal, there is nothing to do about it. So it has to be left like that. So if they see some targets, there is nothing to analyze them or manipulate them. There was nothing to analyze them. So and therefore, during 1970s and ahead, they came in and transistor age, where the analog signals was to be digitized for a computer and change the waveform into binary numbers. You understand? So you get my point. So because of that problem of aging of the system, stability of the system, the sensitivity of the information of the signal, it led to digital era, whereby this analog signal was converted into binary numbers so that it can be easily understood by our system, for example, including the computer and mobile phones, so that it can, first of all, it is highly computerized, the information goes fast, then even the pure signal can be seen, it is very lenient and fast. So all those advantages, we are going to see the advantages of analog signal too over the digital signals. Sorry. So we are going to talk about the advantages, of course. So this one leads to advantages and disadvantages of analog signal over, digital signal processing over analog signal. So we are going to see those are the pros, or we call it pros and cons, or advantage, cons, advantage and disadvantage of digital signal processing. First of all, it is higher noise immunity. offers high noise immunity and accuracy. It is also, it can be upgraded easily. Upgradability. It also has stability and repeatability. Stability and repeatability. It also has, these are all at the advantage side. It also has higher performance with low cost. Higher performance and low cost. It has many advantages here, but I'm going to mention a few of them. Those are 5. I'm going to talk about the first 5. For example, it has perfect reproducibility. You can easily reproduce them again. So here, the disadvantage here, we have a problem of bandwidth. Bandwidth or limitations. We have also system complexity. System complexity. The system itself is very, very complex. We can also talk about they are very expensive. DSPs devices are very expensive. So it is also it needs also more power. More power is needed. So these are the advantages of digital signal processing. So you can see here, it performs, it is immune to the noise. It removes the noise, and it is very accurate, as you can see. It can be replaceable, very easily replaceable. That is, you can upgrade it. It can be easily upgraded. You can easily upgrade it. It is stable. The signal is stable. It's not going in a bubbling way, and you can just repeat it in the naturalist way. It is also low. The performance is very high and with low cost if you are using them, and so on and so forth. So here the bandwidth, it requires high bandwidth using the signal processors to the extent that because of its processing power is very high, therefore it will require some high bandwidth, and this is everyone can understand. And also the system is very complex to the extent that when converting from analog signal to digital signal, it will require those converters from one position to another one, and therefore the signal is complex. The DSP systems they are more expensive to the extent that if you want to buy them, it costs a lot, and also the more power can be observed here. So these are the advantages of digital DSP, digital processing. So if I can go fast and erase this one and go to the next point, we have seen the advantages of DSP. And now we are going to see the advantages of digital, the digital signal processing over analog signal processing, ASP and DSP, so that we can compare about them. So remember, any question you have to send through my email because we are not we could not be able to face one by one, and it can be communicated through my email. Any doubt or any supplement or anything can make our subjects much easier and smarter, so that we can. So we are going to see the advantage of DSP over advantage of DSP over ASP, that is analog signal processing, digital signal processing over analog signal processing. First of all, we look at the noise resistance and high accuracy. So we have seen that at the DSP we have a high noise immunity and accuracy. So that is the first point here. We say number one is noise resistance and accuracy. Number two, that one I hope I explained it in the earlier sessions. So here also we discuss about the flexibility. So DSP has a great flexibility. To the extent that DSP operations can be changed the way you wish. The changing of these signals from one point to another is very flexible and very easier during programming. So it is very easily, it can be easily programmable, and the system doesn't have any disturbances during programming of the DSP programs or operations. Number three, we talked about the stability and the repeatability. Stability and repeatability. So in this sense, it can be easily duplicated, or it can be multiplied into a number of signals, of independent signals. For example, the temperature, aging, and any other external parameters can be connected. For example, if you can see these general purpose computers, not microcontroller not microcontrollers, they can be easily extended, for example, or being stable in the sense that each external devices can be connected to another without any hindrance. Likewise, a DSP or digital signal processors or processing is easily duplicated and independent of the temperature, aging, and so on and so forth, using the external parameters. I hope you can understand this. And also it is very simple, so we call it simplicity. The design or the build-up of the digital system is very easy, hence it is very easy. So designing this one doesn't require much effort to come up with a design prototype, for example. And remember, I talked about something like it can be easily upgraded. As you remember, I said upgraded. It is easily upgraded to the extent that because of software, various software that is available, then it can be seen easily to be changed or upgraded. So you can replace, it can be easily be replaced. And also here there are some other useful or advantages of DSP, including the compatibility, including the remote sensing. And most people in electronics, for example, they do many research during using this remote sensing. So using the stored procedures coming from any area, for example, the external ones. So here, the remote sensing, you can also keep your information using magnetic media, for example, without loss of quality of information, and the production of this can be easily be seen. And also, some cases, in some cases, the hardware can be cheaper. For example, if you want to buy, like our students used to run using an Arduino microprocessor, or those things can be cheap in the other way, so that you can get the quantities or qualities of your shared information. So these are our advantages. Now the next point. So if there is any other question, for example, if there is a query or supplement, I told you there are so many ways of how you can pose your query, or just give some supplement, or any contribution to this topic is very highly welcome. You can pass through my emails as I showed you from the beginning, and please feel free to write to me, and also do some subscribe to my YouTube channel, and share and likes, and that one, so that you will be getting all these videos and notes from my side. So we are going to move to another level where we are going to discuss the application. We have seen the advantages, we have seen the differences, we have seen all those definitions. But where do you think we can apply these DSP techniques? So the application here is going to be seen, first of all, in space. Applications of DSP, digital signal processing. So we begin with space. It is applied in the space. You remember we talked about the radar system, where it was used to capture the targets during Second World War. So here in the space itself, when using all those data, radar, we are looking into space photograph, number one. Space photograph. We also deal with data acquisition or data compression, as I mentioned from the beginning, data compression, to make it fit into any media that you want to store information. Before you store information, of course, you have to deal with, when we talk of space here, we are talking about, for example, where you can store your information. And in this case, you can use it, for example, if, for example, you have taken many pictures or photographs, you want to keep them, you use this space, and also in the end, you do data compression, and also you use, you can get what we call intelligent remote storing of bits Yeah, storing of intelligently. So we were talking about the applications of DSP. We mentioned number one is space, where we can use in space photograph. Of course, we are looking into where we can store our information using data compression, because we want to make it compact so that it cannot utilize a very huge space. And in this side, we are going also to use some sensors or sensoring systems to store the space. For example, if we want to identify what is happening in the space. That is number one. We also have number two, where we are going to apply medical. It is also applied in medical system, where we can do diagnostic images using MRI, for example. We divide them, for example, MRI, diagnostic. We can also have electrocardiogram, or for example, you can generate ECG signal and EE signal. So remember, when you have a brain problem or heart attack problem, you can all identify those signals. You can also retrieve the storage images. You can also have some images. Another application here, as I'm winding up, I'm trying to move so fast so that the time is almost up. So we can also talk about the commercial way. It can be commercialized using the image and sound compressions. Image and sound can be commercialized in this way. It can also be used to use, for example, entertainment or movies. It can also be used to video conferencing, for example. Video conferencing. So this conferencing, you can also use in a telephone. Telephones. Remember, nowadays it is advanced also. We can also use it in the voice and data acquisition, voice and data. We can also use it in the echo restrictions or echo sound restriction. Echo restrictions. It can be used in signal multiplexing and filters, for example, filters, and so on and so forth. So these are among the applications here. I have mentioned 4, but there are many of them. You will just receive them through my notes. There is also military purpose, as you have seen, radar system or sonar, the sonar, sound, navigation and ranging, which is sonar, can be used in the military. It also can be used in industrial purpose, for example, oil mining, CAD and design tools. I mean, computer-aided design and design tools. It can also be used in a processing of or monitoring and control system in the industry. It can also be used in a scientific research, whereby the earthquakes can be recorded, or data acquisition, as I mentioned, or speed and simulations can be analyzed. So those were the discussions for today, and thank you for listening. For any other query, please don't hesitate to send through my emails. I have just given them. And also, please remember to subscribe, share, and like. My videos will be coming regularly to your point. Thank you very much.